similarity, we are proving the same shape, and to prove the same shape we use angles. So proving similarity means proving angles are equal, and that we have a very specific format for it. Like I said yesterday, if you don't get the format right, you don't get your marks. Simple as that. When we are proving similarity, we are comparing two triangles. So triangle 1 and triangle 2. I will prove two angles equal, one from each triangle. I'll prove another two angles equal, one from each triangle. And lastly, I'll prove the third angle, one from each triangle. Therefore, the first triangle is similar to the second triangle. What did I prove? I proved that all three angles are the same. So that was my format. Now we got to the fact that we saw that we had specific names of triangles. So we went on to see how do we name triangles. So I say to you, when it was one triangle in isolation, it did not matter. But normally we do it in alphabetical order. Okay? But when we dealt with two or more triangles, our second triangle must match the first triangle. So what we did was we named the first one, and then we matched the second one. And we saw that even though that was alphabetical, my second triangle was not alphabetical. And then we were busy writing our note on naming triangles. Name the first one using the three letters, match the second triangle and its three letters based on the angles that are corresponding. So let's do a quick recap of everything that we wrote yesterday, and then we will start practicing the proofs. Okay. So I'm going to give you two triangles. I'm going to start on a new page. You can just continue from where you were. Okay, we are 8WY. Today is Tuesday, and we are group 2. So draw the first triangle quite large because we're going to do another one inside of it. Okay, drawing my second triangle inside of it, smaller triangle. Yeah. Not necessarily. I did it like that on purpose because we need to check where they are. So that's a good observation. Okay, who's still busy drawing their triangles? Okay, I'm zooming out a little bit. So I want you to match the angles, please. In my orange triangle, which I've called PQR, I have angle P, I have angle Q, and I have angle R. I want you to match in my green triangle which angle S, T, or U is equal, got the same size as P. So S, T, or U, which one is the same size as P? U. Q, what is the size of Q? Is 60, and I already heard the answer. That matches S. Let me just put this up. Okay, and my last one, R is the size of 100. Which one is 100? T. So now I need to name my green triangle. Remember, the letters must match. Which letter matched P? Which matched Q and T. So even though that one was alphabetical, that one is not. You must match it. Since those angles are the same, it is similar triangles. They are similar triangles. Now, these were the angles that I dealt with. Let's look at my sides. I want to know the corresponding sides. Okay? So I'm just going to use cor as in corresponding. So my first triangle side is PQ in the orange, PR, and the third is QR. And I want to know what it corresponds to. So they're not equal because we can see one triangle is smaller than the other triangle. So I can't use the equal sign. That is why I'm saying corresponding, but I'm not writing the whole word out. It takes too much space. So I'm looking for the matching side in the green triangle. SU corresponds to what? Why did you say that?
Because S and Q have the same amount, and then U and U.
There we go. So he's looking at his angles. He is seeing the Q and P are the angles between 60 and 20, or the side between 60 and 20. So he's looking at the U and S, or the S and U, because that is the side between 60 and 20. P and R is 20 and 100, so that's going to be U and T. And Q and R is between 60 and 100, so 60 and 100 in the green triangle is S and T. So let me just quickly make those in green, so we know that those are my green triangle. So those are my matching sides. And again, you can write US or SU, TU or UT, and ST or TS. That's okay. Any order. But now I want to show you something really cool. If you match your triangle names properly, you can already tell which sides are corresponding. So let's look at my orange name. There are 3 letters. All of them refer to an angle, but when I take 2 letters together, it refers to a side. So my first 2 letters would be PQ, QR, and my first one and my last one, PR. Okay? Now let's just ignore the matching sides for a moment and only look at the name of my triangle. I took the first 2 there, so I'm going to take the first 2 here. I took the second 2 there, so I'm taking my second 2 there. I took the first and the last, so I'm doing the same. Now let's check. Is it the same as what we just wrote? PQ corresponding to US. PQ, SU, yes. Does match. QR and ST, QR and ST. And PR and UT, PR and UT. So if our names are correct, we already know which sides should correspond. The first 2 with the first 2, the second 2 with the second 2, and the first and the last with the first and the last. So now let's put this all together into a question that we would actually receive in a test. Everyone finished? Anyone still busy? Okay, let's look at our first example. So we're going to start off easy, where I give you the names in the correct order. Prove that triangle PQR is similar to triangle DEF. I'm going to give you the 2 triangles. P, Q, and R. 30, 70, and 80. Our second triangle. I'll also zoom it in after I've written it. Okay, I'll zoom in for you. So it's 30, 80, and 70. 30, 80, and 70. So my question says prove that they are similar. So I have to use the format. So just a reminder of what that format looks like. I need to say, oh, that's very zoomed in triangle and triangle. Angle, angle, angle. Therefore, triangle similar to triangle, angle, angle, angle. So that's what my format has to look like. So I'm going to start. In triangle, PQR, because that's what the name says. And I've not proven similar yet, so I can't use the similar sign yet. Triangle, they gave me the name so I can write it down. I've introduced my sum. In triangle PQR and triangle DEF. I need to prove three things. 1, 2, 3. Yes. So my statement is that angle P, which angle is it equal to? D. What's my reason? Well, the only thing is I know that it's on the page. So I say that it is given to me. It is given. Okay, so I've done one angle. Let's go to Q. Which angle matches Q? And that's because I can see 80 and 80. And once again, it's on the page, so it is given to me. And lastly, angle R is equal to angle F. And again, it's given to me. So I have 1, 2, 3 statements. That's my statement. Which angles are equal? My reason is given. Therefore, triangle PQR is similar to triangle DEF. It is angle, angle, angle. But even from the name of the triangles, we should have been able to see which angles should have matched. P and D should have matched because they are the first letters in each name. P and D did match. Q and E should have matched because it's the second letters in each name. Q and E did match. And R and F should have matched because they are the third letters in each name. R and F did match. Now we know that the triangles are similar. Okay? Therefore, they are similar. That means they have the same shape, right? But it also means that the sides are in proportion. That means that they have the same factor between them. They are similar, sides are in proportion, they have the same factor. That means if I divide the matching pairs, all the answers will be the same. Just like we practiced yesterday. But now I need to know which sides, which are my matching sides. No, I'm waiting for you to finish writing. So we just learned that if my names are nice and written in the right way, I can find my matching sides. So looking at my triangle names, I'm taking that out. I don't want you to look at the picture, I want you to look at the triangle name. My first side, PQ, which is the matching side in my second triangle? First two letters, DE. So if I divide them, I would get the factor. My second two, QR, its matching side is EF. Second two in the second one. I divide them and I should get the same factor. Therefore, that factor is equal. And my last one, PR, which matches to DF. I divide them, I get the factor, and it would be the same factor. Because all the sides are double, triple, quadrupled. Yes.
When you divide the numbers.
The numbers that they would have. Currently, we don't know what those numbers are, but whatever those numbers would be, we would divide them. And that answer would be equal to that answer would be equal to that answer.
So the PQ would be that whole line, and then that would be
PQ divided by DE, we would get an answer.
so maybe that's that whole line.
Yes, PQ. This whole PQ
So it's equal to.
would be divided by DE, and we would get a factor. What now?
Apologies for the interruption. Can Lily Bredenkamp please make your way to the front office immediately? Lily Bredenkamp.
So remember when we did the factors, we said increased by factor of something, right? Or decreased by factor of something. So this one looks smaller, so we would say decrease by factor of, and then we found that number, right? Whatever it was. Yesterday we had 2, 3, and 4. So whatever this is what we are calculating here. We are looking for that change between one triangle and the other. And remember we said, well, if that side increases by 2, then this side must increase by 2, and this side must also increase by 2. So that factor was the same no matter which line we used. That is what we are saying here as well. No matter which line we use, that factor is the same. So we divided to find the factor, divided to find the factor, divided to find the factor, and each of those answers must be the same. Which right now seems silly. Why would we have to do it 3 times if I already know they're going to be the same? But we use it to find the missing sides, which we are going to do soon. So right now, I just want you to, every time you prove similarity, write which sides are in proportion. So we'll do another one so we can practice that. Okay. We can now take out our worksheet that you received yesterday. So the first page is everything we've already written, but we can just read it in someone else's words. When triangles are similar, they have the same shape, but have different sizes, i.e. the lengths of corresponding sides are different. And similar triangles can fit inside each other. So you can see a picture there of PQR and STU. And they've drawn it in a way that they are the same. P and S, R and U, Q and T. The symbol for similarity is those 3 lines going down. In the above diagram, triangle PQR is similar to T, U. Let's make sure that it matches. P matches to S, yes. Q matches to T, yes. And R matches to U, yes. Okay, names are fine. This is because the corresponding angles are equal. And they are saying the corresponding sides are in proportion. Note that triangle PQR is double the size of STU. So they give you some sides there. 4 for PQ, 2 for ST. So we doubled the 2 to get to 4. 3 for SU, 6 for PR. So we double the 3 to get to 6. And TU is 5 and QR is 10. So we doubled the 5 to get to 10. So my factor is the number 2. I times by 2 to get there. We can prove two triangles similar in 2 ways. So I told you in grade 8 we only focus on the one, and that's the bolded one, where we have 2 pairs of corresponding angles equal, and therefore the third is also equal. So 3 pairs of angles equal. And my final reason would be angle, angle, angle. So A, all the little symbols for angles. The other way, which is what we're doing in grade 9, is where we do the opposite, where we prove that they are corresponding sides are in proportion. The layout for the proof is important, and it is the following: in triangle, dot, 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 and triangle, dot, 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 statement, reason, statement, reason, statement, reason, and therefore they are similar, angle, angle, angle. So our first example, and Ms. Saunders has used 3 letters, so we're also going to practice using 3 letters, not just 1 letter. Consider triangle ABC and DEF. Prove that they are similar. So we can see the angles. So using 3 letters for an angle. So BAC would be the same as EDF. It's on the page, so it is given. ABC is the same as DEF. On the page, it is given. And ACB is equal to DFE. It's on the page, so it is given. Therefore, ABC is similar to DEF, angle, angle, angle. On that page, I want you to please write for me which sides would be the matching sides. On the page, next to the proof. So for instance, if I choose the first 2 letters, AB, my second 2 letters, BC, and my first and last, AC, I want you to do the matching ones for me, please. Divide by the matching sides. So we're writing down the matching sides, please. What matches AB, what matches BC, and what matches AC? Okay, what matches AB? What matches BC? And what matches AC? No, wait, I made a mistake. DE, EF, not DE. Okay, so first 2 and first 2, second 2 and second 2, first and last and first and last. And since we are working out that would be the factor, all those factors have to be the same. Let me just fix mine. EF and DF. So now, that's easy peasy, right? Everything's given to me. I'm just writing given, given, given. But we are going to get to a point where not everything is given. We sometimes have to calculate. So that is what we are doing in our first example of exercise 1. So we will do that very first one together. But now Ms. Saunders, please hurry up. Ms. Saunders also didn't tell us the triangle name. So now we have to do extra work as well. Okay? So in my first one, there's my two ones. Let me zoom it in for you. Or you have it in front of you, so I don't have to zoom in too much. No, you have it the worksheet, so you don't have to redraw it. But you are going to write the notes in your books. So if you want to, you can say exercise 1 from the worksheet. So exercise 1 from the worksheet, number 1. Okay, so remember I said the first triangle, Aiden, you can choose. So in triangle, I'm going to do it alphabetically, S, T, and U. That's my first triangle. And triangle. Now I'm stuck. I don't know what matches S, T, and U. So for the time being, I'm just going to leave it. I'm not going to struggle too much. I know that it's going to get a name. But let's see if we prove it, if it will make it a bit easier to see what that name is. So the first thing I can clearly see in these two triangles is that triangle STU, using 3 letters, STU is equal to WVX. I will. Sorry, I can see that you can't see it. Okay, so STU is WVX. That's on my page, therefore it is given. And so far, that's the only thing I can say. Yes. So remember, we like the 1 letter, but sometimes Ms. Saunders wants us to do the 3 letters. So we have to practice it, okay? So I'm only worried that the T and the V is in the middle. I don't care about the order of the other letters. The T must be in the middle, and the V must be in the middle. Now, currently, the angles that are given don't match. But they've also not given me every angle. Can I find that missing angle in each triangle? Doing what? Pardon? It's our geometry. No, that's parallel lines. What am I dealing with? The inside or the outside of a triangle? The inside. Interior angles of a triangle add up to 180. So, to find in this first triangle my angle U, I'm going to do it on the side so that it's not part of my format. So just somewhere below. It is triangle STU, and I'm trying to find U, so I'm going to say SUT plus 70 degrees plus 30 degrees equals to 180 degrees. My reason for that? Int angles of triangle. Therefore, SUT is equal to 180 degrees minus 70 degrees minus 30 degrees, which is 80 degrees.
Ma'am, couldn't you just, instead of calculating, you say 8, couldn't you just figure it out?
But remember, in geometry, we have to show everything. We can't just do it in our head because I don't know what you're thinking. So you have to show it. So now we know that this one is 80. So now let's calculate. Do we have a matching 80 in the other triangle? So I'm going to write that down. S-U-T. What is my matching angle? W, but with 3 letters, it would be VWX or XWV. But now that's not given. We use the fact that it was the interior angles of a triangle. So there's my first statement. We had to calculate to get my second statement. I'm going to have to calculate again to get my third statement. So angle VXW plus 30 degrees plus 80 degrees equals to 180 degrees interior angles of triangle. That means VXW is 180 minus all of those things, which would be 70 degrees. Do we have an angle in STU that matches 70 degrees? So we're going to write it down. TSU is equal to VXW, and it is interior angles of triangle. There's my third statement. Therefore, triangle STU is similar to triangle. We still don't have a name for my triangle.
Hi, Mr. Sun.
Yes.
Hi, Sun.
Yes.
Sorry to bother you. Could Ethan Francis please come down to the front office with his bags?
He's on his way.
Thank you.
So we still need a name for my triangle. Okay? So we just need to match now. What matches S? Well, let's look. S was matched by X. What matched T? T was matched by V. By Ethan. And what is matched by U? W. So my triangle names are STU and XVW. So I went back and gave the name in the correct order. Okay? And that is the kind of question that you can expect in a test. And I said the last thing I want you to do is just to write your sides. Therefore, what corresponds to ST? That is equal to TU divided by, which is also equal to SU divided by XW. What's wrong? Okay. So we like the ones where all the information is given, but sometimes you have to use your geometry reasons to solve your angles. So we'll do one more together. I want you to look at number 2 for me. Yes. Yes, it is. Sorry, it's supposed to be TSU, yeah. Thank you. SU and XW, first and last. Okay, look at the number 2 on your page, please. Number 2. I have 2 triangles there, in no particular order, so I'm not matching the names. Anyone still busy on the board? Okay, so not matching names. I know that I have this top triangle, and I have this bottom triangle. Okay? I can see that A and E have the same size because they give that to me. But I need to prove 3 things. That's only proving 1 thing. So I still need to prove the other 2 sets of sides. But now I need to use geometry reasons to find what they are. Does anyone have any idea what we could use? Remember, there are 9 reasons, 3 of which only pertain to parallel lines. Do I have parallel lines? No, I'd have no arrows, so no parallel lines. So I cannot use alternate, corresponding, or co-interior. So I only have 6 reasons that I can use. Angles on a straight line. Vertically opposite angles are equal. Interior angles of a triangle. Exterior angles of a triangle. Angles of a revolution. And I don't know what the other one is right now. Doesn't matter. We won't need it because, yeah. So those 5 reasons, we need to check which one's going to help me to find something here. Laszlo. Angles of a triangle. But I only have 1 angle. I need 2 angles to be able to use interior angles of a triangle. Pardon, Gabby? Or Shakira, who was it? Angles on a straight line. So here's my straight line, or there's a straight line, which means those 2 angles, or those 2 angles, or those 2 angles. Here's a straight line. If I extended it, it would be that angle and that angle, so that's not going to help us right now. And now, vertically opposite angles. At which point? A, B, C, D, or E? At which point do I have vertically opposite angles? Look for your cross. You are just making up letters. At C is my cross.
Oh, C.
Which means that this angle is equal to that angle. So that is using vertically opposite angles. Now if I have 40 and I know that those are equal, I don't have the length, the size though. Can I make something about these 2 angles? If I know that 2 angles are equal, doesn't that automatically mean the 3rd one also has to be equal? Doesn't matter what the size is, and that's exactly what we are going to use here. So now we're going to put it into a sum. So we don't know the names yet, so we'll just start with my first one. In triangle, I'm going to call it ABC. And triangle, I don't know the name yet, so we're going to leave it just like that. I'm going to write the one that I can see first. BAC. BAC is equal to CED because that is given to me. And then Anam very nicely pointed out that we have our vertically opposite, not yet, it's breaks, we still have 2 minutes. ACB is equal to DCE. It's not given, it is vertically opposite. Angles are equal. Therefore, we have 2 angles. The 3rd one must be equal.
It is the first break valve for bottom of B wing and C wing to be dismissed now. Thank you.
So my 3rd angle, ABC, is equal to CDE. Why? Because it is the 3rd angle of a triangle, or you can just say interior angles of triangle. Either reason is fine. So we have 1, 2, 3 statements. Therefore, triangle ABC is similar to triangle whatever, angle, angle, angle. So let's match. What matches A? A matches E. What matches B? B matches D. And C is matched to E. Sorry, I think I did this one wrong. Yes, I did. A, B, C, C, no. A, C, B, and D, C, E. Sorry, C and E. Not packing up yet. So then it would be A and E, B and D, C and C. So just writing it here as well. And the last thing we do is match the sides. Therefore, AB divided by ED is equal to BC divided by DC is equal to AC divided by EC. So that is what a perfect answer would look like. Once you have copied everything down, you may then pack up.